Welcome back to part 2 of the unit circle. So this is where we left off in the previous video. If you didn't check out the previous video, definitely make sure you go back. I'll have a little link up top. Definitely make sure you go back and watch part 1. Otherwise, this is going to make no sense. Okay? So we left off right here. We left off at realizing that to find the x-coordinate of that point of intersection, we simply do cosine of whatever that angle is, and to find a y-coordinate, we simply do sine of whatever that angle is. Okay, so let me break this down just a little bit first. We're going to kind of go angle by angle. I'm going to try to color coordinate this. All right, now I'm going to start with these points of intersection first, where the circle actually intersects the x and the y-axis, because these are actually the easiest ones to figure out. Well, if we think about it, this point here would actually be 0 degrees. I didn't rotate at all. If I rotate it up to here, that would be 90 degrees. And if I rotate here, that would be 180 degrees. If I rotate down here, that would be 270 degrees. And if I do a full circle, I'm back at 360 degrees. Okay, and make sure you're able to get this in radians as well. Remember, 360 degrees is 2 pi radians, 180 degrees is pi radians, and definitely make sure that you're able to convert to radians. Okay, if you haven't watched the radian introduction to radians video, definitely make sure you go back and watch that as well. I'll have a link up top. All right, now to find what these coordinates would be, we could go ahead and actually use sine and cosine, but with these it's actually a lot easier. Okay, what you need to remember is that the radius of the circle is 1. So if this total length here is 1, and I'm intersecting on the positive side of the x-axis, that'll just make this point 1, 0. And this point here would just be negative 1, 0, because I'm on the negative side of the x-axis over here. And if I kind of follow that train of thought up here, it would be 0, 1, and down here it would be 0, negative 1. So let's go ahead and fill that out. So I'm going to scroll down here and kind of fill that out. So this was 0 degrees, which is 0 radians. That point is 1, 0. If I rotate 90 degrees, which is pi over 2 radians, I'm now at the point 0, 1. If I rotate another 90 degrees, so a full 180, which is pi radians, I'm at negative 1, 0. If I go a little bit further to 270 degrees, which is 3 pi over 2 radians, that's 0, negative 1. And if I do a full rotation of 360 degrees, which is 2 pi radians, I'm back at 1, 0. Now I put all those in the same color because these are all along the x and the y axis. Those are points literally on the x or y axis. Okay, so they share some important characteristics. They have roughly identical coordinates, right? Over here we had 1, 0, flip side negative 1, 0. Up here we had 0, negative 1, flip side 0, negative 1. That kind of a relationship is actually going to stay true throughout this unit circle. You'll see in a little bit. Okay, now back up here. Now what I want to do is I want to break this down a little bit further. So I'm actually going to draw just a new little circle over here. Okay, and let's say I rotated 45 degrees. Okay, let's say this rotation was 45 degrees. So what we're going to do is we're going to break down our 45 degree measures. Okay, so we're going to be using those 45, 45, 90 special right triangles. Okay, actually I'm going to kind of make this a little bit bigger if I can. Let me see if I can maybe, no, I'll just stay right here. So that's better. So I'm going to rotate 45 degrees. I'm going to rotate 45 degrees. So I want to know what this coordinate right here would be. Well, I can make my right triangle. And to find the x-coordinate, I would actually just go ahead and use cosine. So to find the x-coordinate, let me use a different color here. To find the x-coordinate, well, x is equal to cosine of theta. So right here, that x would be equal to cosine of 45 degrees, right? Because this is 1 right here, so that would be cosine of 45 degrees is equal to x over 1. So x is cosine of 45 degrees. And you should remember that cosine of 45 degrees is root 2 over 2. So this coordinate right here is root 2 over 2. The y-coordinate, well, to find a y-coordinate, I'll jump over here. To find a y-coordinate, well, that would be sine of 45 degrees is equal to y over 1, which is just y. Which tells me, well, sine of 45 degrees is also root 2 over 2. So that tells me that this coordinate here would be root 2 over 2, comma, root 2 over 2. All right. Now, I'm going to go ahead and make another right triangle in the second quadrant with the 45-degree measure. Okay, so I would follow pretty much the exact same setup. To find x, that would be cosine of 45 is equal to x over 1. So x would once again be root 2 over 2, and y would be sine of 45 once again, which would end up getting me root 2 over 2. The only thing is that we're in quadrant 2 over here. And in quadrant 2, x is negative. Look, x was negative in quadrant 2 over here, but x was positive over here. Well, that holds true, so that's going to be negative root 2 over 2, comma, root 2 over 2. And what we need to think about is what this full angle actually is. Well, if I went full 90 degrees and another 45, that means that this full angle here is 135 degrees. So think about that. 135 degrees and 45 degrees have the same reference angle, and because they share the same reference angle, they share roughly the same exact coordinates, the same x and y coordinates. X was just negative at 135 degrees because we're in quadrant 2 where x is negative. And y was still positive root 2 over 2 because in quadrant 2, y is still positive. Okay, so we can kind of fill that in. So here at 45 degrees, the coordinate was root 2 over 2, comma, root 2 over 2. And here at 135 degrees, it was negative root 2 over 2. Comma, root 2 over 2. Okay? And that's very, very important. Notice that if they have the same reference angle, they have roughly the exact same coordinates. Okay? Well, I can kind of keep going here. If I made another right triangle in quadrant 3, if I made another right triangle in quadrant 3 with a 45-degree measure, I would have roughly the exact same coordinates. It's just that we're in quadrant 3 now, so x would be negative and y would also be negative. And think about what that full rotation would be. We'd go 180 degrees and another 45. Well, that would end up being 225 degrees. And the same exact thing would happen over here if I created another 45-degree reference angle in quadrant 4. That would be a full 315 degrees, right? Because I would go 270 and another 45. That's 315. I would have pretty much the exact same coordinate once again, except in quadrant 4, x is positive and y is negative. Okay, because these all shared the same reference angle of 45 degrees, that's why they have roughly the exact same coordinates, because we are still just doing sine and cosine of 45 degrees. Okay, so if I come down here, I can kind of keep filling this in. That's 225 degrees, that's 315 degrees. And at 225, x and y are both negative. So we have negative root 2 over 2, negative root 2 over 2. And in quadrant 4 at 315 degrees, x is positive and y is negative. So notice all these 45-degree reference angles have roughly the exact same coordinates. Okay, and we should be also labeling the radian measures. So make sure you're able to convert. We got pi over 4, 3 pi over 4, 225 degrees is 5 pi over 4, and 315 degrees is 7 pi over 4. And another kind of important thing, notice that all the 45-degree reference angles, okay, have radian measures that have pi over 4. Oops, gonna die. So make sure that we're practicing with this. In our next video, we are going to talk about the other special angles. So the next time, goodbye.